Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi and we continue with our topic of discussion. The topic is acids, bases and indicators. We are on the third property where we are discussing neutralization, which means the reaction of dilute acids with bases. And remember we say that bases can either be metal oxides or metal hydroxides. We also learned that those bases that are soluble in water, we refer to them as alkalis. And we also have other bases that are insoluble in water. So we're going to have equations showing acid-base neutralizations. Equations showing acid-base neutralization. And the first one we had used the dilute hydrochloric acid and sodium hydroxide. So we expect to get a salt and water only. So the salt will be sodium chloride. Sodium chloride. Remember we said that from hydrochloric acid we get chlorides. And then of course the other product is water. So we have the acid and this is the base. And of course this is what we are calling neutralization. So from this we can be able to define what is an acid and what is a base. For example, we can say that an acid is a chemical substance that reacts with a base to form a salt and water as the only products. And we can say that a base is a chemical substance that reacts with an acid to form salt and water. So we can say that an acid is a chemical substance that reacts with a base to form salt and water only. So an acid is a chemical substance that reacts with a base to form a salt and water only. So we can also define a base. On the other hand, a base is a chemical substance that reacts with an acid. Reacts with an acid to form salt and water only. So we have seen that we can use that equation to define what is an acid and also to define what is a base, because we are saying that an acid reacts with a base to form salt and water. A base reacts with an acid to form salt and water. So more examples. We can have an acid such as sulfuric acid and a base such as magnesium oxide. Remember, a base can also be a metal oxide, not just a hydroxide. It can either be an oxide or a hydroxide. So here we'll get a salt, magnesium sulfate, plus water. We can use nitric acid plus calcium hydroxide is still a base. So we'll have calcium nitrate plus water. Another example, we can use phosphoric acid plus sodium or potassium. Let's use potassium hydroxide so we'll have potassium phosphate. So we'll get a phosphate because we are using phosphoric acid. Plus water. So in all the acid-base neutralization, there must be a salt and water. Salt and water. Different salts depending on which acid we have used. When you use hydrochloric acid, we get a chloride. When you use sulfuric acid, we get a sulfate. When you use nitric acid, we get a nitrate. When you use phosphoric acid, we get a phosphate. So that is basically that as far as the neutralization is concerned. You can still take one more example and say, for instance, lithium oxide plus hydrochloric acid is going to give us lithium chloride plus water. So in all these examples, we are forming a salt and water. In a neutralization reaction, an acid-base reaction, salt and water are the only products. And that's why we defined an acid as a chemical substance that reacts with a base to form salt and water. We also defined a base as a chemical substance that reacts with an acid to form salt and water only, or as the only products. Can have our assignment. So we have two questions in the assignment. The first question, what is neutralization? The second question, complete the following equations. A, potassium oxide plus sulfuric acid, you complete that. Sodium hydroxide plus nitric acid, you complete that. And then calcium oxide plus phosphoric acid, you complete that. So we're going to stop there for today. Until the next time, goodbye.